Welcome everyone to the third event of Artificia. Artificia is a brand new platform for promoting and sharing knowledge of augmented creativity and the use of artificial intelligence in arts with all kinds of audiences. From the platform's website, artificia.pro, artists, experts, and researchers can show their projects and promote a debate around the interaction between technology and the arts in the creative process. Artificia is a collaborative project. Research centers like the Artificial Intelligence Research Institute of the Spanish National Research Council the Music Technology Group at the Pompeu Fabra University, and other educational centers like the Escola Superior de Música de Catalunya have contributed to the studies and information provided by Artificia, along with companies like the Visual Suspects, UPF Ventures, or Creo Musica, as well as music festival like Corilla. After the first event, held on March 10th, covering the use of artificial intelligence in musical improvisation, and the second, held on April 8th, dedicated to music composition with AI, we will focus this third session on musical performance and education with AI. So, let's begin one more time from Pompeu Fabra University. Let me introduce our guest moderator, Sergio Giraldo. Sergio is a postdoc researcher at the Music and Machine Learning Lab of the Music Technology Group and the professor at the Department of Communication Technology at the Pompeu Fabra University. Since 2011, his main research has been focused on machine learning, expressive music performance modeling, emotion detection with brain-computer interfaces, automatic music transcription, and music learning and teaching technologies. Sergio, we are very happy to have you conducting this third event for Artificia. Thank you for your support and generosity, and now, it's all yours.
Okay, so good afternoon and welcome everybody. Thanks for this nice introduction, Nicole. And also thanks to all the Artificia team, Leticia, Xavi, Paul in the production, and everyone for inviting me to join this great event and all these great sessions that have gone through these days. It's a great honor to be here. Let me introduce the session with a very brief reflection regarding music education and performance and AI. So AI has permeated our society at several levels. Nowadays, AI is present in our day-to-day life, even without noticing. For example, our spam email filters or our recommendation systems in the social media platforms or the music playlists that we all use every day, to more complex applications like applications in healthcare or self-driving cars. So yes, AI has transformed the way we interact, the way we do business, the way we search for information, the way we live. I would like to cite Andrew Ng, the creator of Coursera. In one of his courses, he makes a parallel between the impact that AI is having in the transformation of our society, from transportation, manufacturing to healthcare and communications, with the impact that electricity had in society 100 years ago. And in this sense, I think there is a huge potential for AI applications in the context of music performance and education. For instance, nowadays we are living in a global pandemic, unfortunately, which has had a huge impact in music in general, for music practitioners, for music professionals, and in general in the music industry. And current artificial technologies are capable of exploring, for example, large amounts of multimodal interaction data. And this allows to propose new interaction models and tools. Given that music performance involves nonverbal communication and the interaction is a multidisciplinary phenomena based on semi-motor, cognitive, and social skills. I think AI is a promising avenue for researching and proposing new tools in this context. Also, in the field of music education, AI can provide a promising path to enhance the learning process in both the traditional teaching scenarios and the self-learning context. For instance, music has traditionally been taught in using the master-apprentice model. And on the other hand, there is a offspring of online platforms and music applications, social media lessons and tutorials, which are gaining a lot of popularity among musicians and music practitioners. However, the restriction of short and punctual interactions with the professor, or even the lack of a professor, might result in periods of self-learning and self-practicing that might lead to the acquisition of bad technique habits, which may also result in high abandonment rates, or even worse, in many cases, physical injuries. So to summarize, AI can transform the way we learn and the way we perform music. And in this session, we will be discussing some of the topics we're presenting, very interesting projects. And I hope that we can create a very interesting and engaging discussion towards this fantastic topic. So let me introduce the participants for today's session. Okay, so in this event, we have the privilege of having with us researchers and educators in music technology, AI, and creativity. They will show us some projects and performances based on artificial intelligence and how interaction with AI can enhance music learning and music performance. So today we have Rafael Ramirez. He's the leader of the Music and Machine Learning Lab at the Music Technology Group from the Pompeu Fabra University. We have George Waddell. He's a research and associate professor and researcher in the performance at the performance science of the Royal College of Music of the Imperial College in London. And they will be presenting the Tell Me project. We have also Anna Chambaud. She's a researcher and experimental electronic musician and producer at Manford University, and she will be talking about the Mirkla project. Also, let me introduce Elisa Pereira. She's a musician, engineer. She holds an academic position at the New York University Interactive Telecommunication Program, and she will be presenting the code of music. And also we have in the panel Enrico Aus from the SMUC, the Catalonian School of Music, and also Alia Morsi, that she is a PhD student at the department. And they will be also participating and sharing some ideas and reflections today with us. So I would like to thank all the attendants, and I would like to remind to the audience that you can use the chat to ask questions during the event. Okay. All right, so we will start with Rafael and George. Welcome, Rafael and George. As I mentioned before, Rafael leads the Music and Machine Learning Lab at the Department of Communication and Technologies at the Pompeu Fabra University. He is a professor at the university and researcher. His main work is in machine learning applied to music. And also, he has also studied classical violin and guitar. He's a great performer at the National School of Mexico. I have listened to him, so he's very good. And also we have George Waddell. He's a research associate in performance science in the Royal College of Music. And his research focuses on the evaluation of performance and how technology can enhance the performance and how performance is assessed and learned. Let me quote as well that George is a great pianist. I haven't heard him yet, but so Rafael and George will be presenting the Tell Me project. And so Rafael and George, the floor is yours.
Thank you. Thank you, Sergio. Thank you for the very nice introduction. I don't know, maybe I start and then I ask George to comment and complement. We want to present the Tell Me project we are going to talk about. And Tell Me project was a project funded by the European Commission under the Horizon 2020 program as a research and innovation action. And it, as most projects of the European Union, they have different partners, different institutions that were playing an important role in the research of in the project. And in our case, we had 3 academic institutions. It was Royal College of Music, one, where George was the main person. Then University of Genoa, and the third one was ourselves, Universitat Pompeu Fabra. And we have 2 companies, one based in Barcelona, 2, Cycle Intelligence, and also another company in London with High Skills. So it was a very nice team. And then the main aim or the main objective of the project was to enhance music learning using the violin as a case study. So we tried to use technology to enhance teaching and learning of music instruments using the violin, which is a very interesting instrument. So in our case, just to finish, our role in the UPF was to apply signal processing techniques, motion capture techniques, and artificial intelligence techniques to try to analyze the performance of experts and also the students in order to provide tools to give real-time feedback, informative feedback, and personalized feedback to students when they were learning. So that was the technical part. The Royal College of Music was more in charge of the pedagogical, and maybe George can tell us about it.
Sure. Well, a real pleasure to join today, and it certainly it was a real pleasure for us at the Royal College of Music to contribute to this project. As Sergio mentioned earlier, I mean, technology and music really go hand in hand. Most aspects of what we do as musicians, whether it's composing music, creating music, recording it, sharing it, and also the way our audiences engage with music is through technology. And of course, that's particularly true, during a global pandemic. But when we look at the act of learning music, and particularly the way it's learned in the Western classical tradition and at the highest levels, we still rely on centuries-old models of teaching. You take a master performer, a master musician, you put them in a room with a younger musician or less experienced musician, one in their training, and in that hour, you hope that expertise and experience is passed on so that the student can then go and work on it in the intervening time in the week. And it's also the case that when they're in that room together, in most cases, there's relatively little technology, maybe a metronome, maybe a tuner, but otherwise it's 2 people, an instrument, some musical material. So one of our goals on the Tell Me project was to really understand what is the relationship between musicians and advanced technologies, whether it's motion capture or artificial intelligence. Where are the opportunities where these technologies can enhance this kind of training, but also what are the barriers? Where are musicians, especially at the highest level, where might they be skeptical of new technology? Where might technology get in the way of these traditions of teaching? So we're very fortunate at the Royal College of Music to get to train some of the finest young musicians in the world, being taught by some of the finest teachers in the world. So we had a great opportunity here to work directly with those musicians in designing the new technologies on the Tell Me project, and really making sure that they would enhance these traditions, enhance this process of musical learning in a way that was complementary to the way that music is taught and is learned traditionally.
So I think, just to complement this, I think there are many opportunities for artificial intelligence in this context that George has described, because there are so many interactions, and then the data that musicians share is by nature multimodal. We have sound, of course, the sound is important, also movement, gestures, and also muscle activity, posture. Even we studied at some part in the brain activity, what's going on when you learn, when you perform music. So artificial intelligence thrives in this kind of setting in which you have so much data that has complementary properties, and then artificial intelligence can detect patterns. And then, for example, you can use sound to give feedback, informative feedback about movement, because of course there are relationships between these two and so on. So it was a really interesting, and for us it was as well such a pleasure to be able to work with the Royal College of Music, because we don't have the expertise. I mean, we are not a music school, and then being able to try to help or to see how our skills or expertise could be applied in a real life setting, in a top class conservatory, music school or music conservatory was such a delight. So I don't know, maybe we can show now a video on some of the tools. I mean, we have the project was much broader. We did many other things. As I was saying, brain activity. There was Genova doing some motion capture for some kind of posture of the body. But then we can show us a short video on some of the technologies that came out of the Tell Me project. A particular software called Skynote, which analyzes sound, analyzing motion of the student in order to give feedback on how to improve.
Now in bar 20, we have an exciting little quick passage of 16th notes. Here, our second finger again hops. And a little faster. Remember to keep your fingers light. And again. Sound color is extremely exciting. Every sound has to have those little nuances and colors. Sometimes the red could be a little bit more black. Sometimes the red could be a little bit more white. It could have a little yellowish tint. It could have a little greenish tint. It could have all sorts of little tints and nuances. That's what we have to look for in sound as well. Let me give you an example. Let's just take one note. Let's just see the G. Let's just say we do different colors with the vibrato, with the sound. We can play a gentle sound. You can play a very excited, warmer sound, tighter sound, Sweet sound. The gavotte, as you see, is full of dots all over the notes. What do those dots mean? It means we need to play staccato or short. So how do we do that? Now our right arm gets to be busy. And what we need to do is we need a quick reflex in our right wrist. So when we play a down bow, we flick that wrist over to the right, and then up bow to the left. Right and then left with a quick motion. It's a reflex motion. Don't get tight. Okay, let's try it with open string. Set your bow on the string, and then first move to the right, and then to the left, and then again, and again. That's it. Now let's try it with the notes in the first bar. Here we go. That's it. Now let's try it a little faster. Let's flick that wrist really quickly, eye to either side. That's it. Very good.
Right. So just to comment quickly on what we have seen, I was mentioning that we wanted to provide feedback, personalized feedback to students, and we recorded, initially we recorded experts performances of experts playing some pieces, and then we extracted the patterns that make that correct playing, assuming that playing correctly, and then use the artificial intelligence in some cases to try to model what they are doing correctly, and then see how student gets closer or not to that ideal performance. So we built tools for all the kind of stages in music, or most of the stages in music learning, from sound production. When in the violin you have to produce a sound, so how to produce a good sound, and then try to give feedback how good you are producing the sound or not, or different colors as he was shown in the video. Then to correct notes playing, like in the right time and the right pitch at the right time, which is the minimum you have to do to play the correct time and the right note. Also tuning the intonation, if you are playing really the pitch, the correct pitch, or you are a bit out of tune. And then gestures, how to, what are your gestures if you are playing a straight bow, perpendicular to the strings, so to give you feedback on this. Also on bow techniques, if you are playing staccato or martelé, like in the video that we're showing. And finally, expression. There was no video on expression, but we have been working on, like Sergio also have been working on in modeling music expression, and then how to guide. There is no right or wrong expression in a piece, but how to guide someone to incorporate some expressive resources into their playing. So that was, I don't know, and was probably you can, George, say about experience at the Royal College of Music.
Well, you can see in those videos a few examples that were built around the kind of feedback we got from students. So wanting feedback about the performance, for example, to be written directly to a musical score. So you saw that there, that feedback appearing immediately on the music they were playing. You saw examples of taking very complicated ideas such as timbre and it being visualized in very simple ways using colors and using shapes. I mean, this is something musicians do all the time, translating these very complex concepts into these simplified ways of talking about them. And certainly our experience of working with the musicians at Royal College of Music and elsewhere was we found that very quickly these tools were not only giving them insight into their own playing, but giving them a new way of talking about their playing with each other, with their teachers. We had an incredible moment working with the concertmaster from a major European orchestra, and she was there with some of her students. And one of her students was doing a bowing exercise using the visualization you just saw, where the bow was transferred to sort of a stick moving through space and tracing these patterns. And in a moment, the concertmaster, the great violinist, she got very excited. She said to her students, well, look, I've been telling you for years, you're not doing this pattern consistently. Your bow is moving in this way. And the students, now that they could see their bow on the screen moving in real time, being able to visualize it, could all of a sudden see this and immediately corrected it. So after years of being told this verbally, it was being able to see it, and then having the artificial intelligence being able to break down playing into these new ways of expressing it, new ways of sharing that. It helped her improve her playing. We also conducted some experimental trials of the software, and we found when musicians were given it for the very first time, only given a few minutes to learn it, that they could improve their playing, have twice the amount of improvement within 10 minutes as compared to students who were just left to their own devices without the technology. So we were very excited to see that musicians found this very easy to use, very easy to pick up, and something that genuinely helped them in their learning as they address these technical aspects on their own, so that when they then go see their teacher each week, they can focus less on technique and movement and more on these larger questions of interpretation and style, and make the most of the time they have with their teacher.
Great. Yeah, thank you. It was great to hear that. I mean, for us as engineers, is like music to our ears. So to hear that what we do, it has some utility. So I think because on the interest of time, we're going to finish with a video in which you will see one of the experts that we recorded. It was recorded in Genoa, in Italy, with different sensors, like position. They were like different markers that the 3D cameras were following. It was also recording muscular activity, EMG, electromyogram activity, about the right and left arm, and you will see playing a beautiful piece and putting expression into it. So we'll end up with that video.
Okay, so George and Rafael, thank you very much for your presentation. So there is a question from Ramon Lopez de Mantaras. He's asking, are you aware of the PRIZE European project that the AAI was involved?
Yes, I mean, we are colleagues, Ramon. We know each other. I think I actually met with some of the members of the project, and we unfortunately we didn't work together, and we didn't at the end we didn't have any collaboration. But yeah, we are aware of the work. Is that other projects, not only the TELMI project, but there was also in the past other European projects similar aims, like the Maestro project and other projects. But yeah, I'm working. Yeah.
Okay. Okay, thank you very much. So, I would like to add perhaps very briefly about the TELMI project in which I was involved as well. Perhaps to briefly mention that it's very interesting to listen to George comments on how musicians received the technology and how they were able to interact with the technology. I think, or at least in my opinion, there is a big gap usually in what technology is proposing and what musicians and the actual schools are willing to use or to accept, especially in the more traditional learning environments. So it was I think it was very interesting to listen to George comments on how musicians were reacting, and I think George, you were more close actually to the reality scenario in which musicians were working with the technology. So I think that is a very nice comment and outcome. Okay, so thank you very much, George and Rafael. So we will move to the next project. So
Thank you.
Yep. All right, so for the second presentation, we have Anna Chambaud. She is a senior lecturer in the music and audio technology at the Montfort University at the UK. She is a member of the Sonic Creativity Institute. Also, she leads a network that investigates the use of AI in live coding practices, and she's involved in initiatives to improve women participation in the music technology sector. She is also an international performer. So welcome, Anna. And Anna, the floor is yours.
Thank you, Sergio Giraldo, for this nice introduction. So live coding brings together music and code in live performance and has been practiced for almost 2 decades. Collaborative music live coding typically involves a group of at least 2 network live coders who can be either in the same place or distributed in different spaces or both. And live coding using online crowdsourced sounds can be seen as a type of synchronous collaboration. This approach can bring a rich, multifaceted range of timbres. However, there is a risk of unpredictability of search results. And so the use of a virtual agent can complement a human live coder in her practice, reducing this potential issue. It can also be helpful to reduce other drawbacks in live coding, such as reducing the time for generating code and complementing the human live coder with novel insights. So Milk Auto, in short Milka, is an EPSRC HDI Network Plus funded project that explores live coding and machine learning to address the research question of whether we can build a virtual agent that learns from human live coders using machine learning algorithms and a large data set of sounds. So Milk Auto has been developed as a tool that enables live coders to design a customizable virtual companion to help live coders in their practice by learning from their preference within situated musical actions. Milk Auto takes inspiration from the interactive machine learning approach, enabling the training process to be carried out with a series of methods and processes integrated into the live coding workflow. The piece that you will see next is Sonic Haikus, which is a premiere and is a collaboration between a human live coder and a VA. Milka is a self-built super collider extension and a follow-up of the also self-built super collider extension Milk. The system combines machine learning algorithms with music information retrieval techniques to retrieve crowdsourced sounds from the online database freesound.org, which results in a sound-based music style. This piece explores the sonification of 5 haikus. Haikus have a highly constrained structure, which finds commonalities with the high-level and also constrained Milk language. Haikus use natural imagery to make Zen-like observations about reality, which can be enhanced with tag sounds from freesound. In this performance, the live coder explores the online database, but only retrieving sounds predicted as good sounds when using the retrieval methods from the live coding system, in this case, sounds by tag. This approach aims at facilitating serendipity instead of randomness in the retrieval of crowdsourced sounds. The VA has been trained to learn from the musical preference of a live coder, in this case me, within context-dependent decisions, that is, situated musical actions. A binary classifier based on a multi-layer perceptron neural network has been used for sound prediction. So I hope you enjoy the piece. Thanks.
Okay, Anna, thank you very much for your presentation and for the nice piece that you just showed to us. Well, I have a couple of comments or questions, maybe just to create some discussion, and maybe we can extend the discussion later. But one topic that I was thinking during your presentation was the possibilities that these type of implementations have, and also I was reading a little bit about your background on music interaction. So I was very much with the idea of how can interaction be improved by AI, artificial intelligence, and how this type of approaches can promote perhaps interaction or generate inclusiveness or be applied, for example, in long distance scenarios, or do you want to extend?
Yeah, so I guess, well, now I'm hearing some echo. Is that? So I guess, thanks for the question, Sergio. So I guess with this tool, it has been really designed for the live coding environment. So, but thinking very much on the interaction aspect. So that's why the training brings this interaction as part of the kind of the activity. And even it could, so, and therefore you just, the borderline between training and performing is smoother, I would say, than in other contexts. And that's because, yeah, it's influenced by this interactive machine learning approach, or a human kind of based and human-centric, if you like. And I guess this could be also transferred to other music performance activities and using other music technologies, where like interaction is kind of the central aspect, and therefore you can also bring like this interactive machine learning and this human-centric aspect to the whole process. But also that means that the kind of the musician who's part of this training, controlling this training, also can learn through the process and can get insights on this the use of machine learning. Yeah. So.
Okay. Yeah. Thank you very much, Anna. And now we will go to the next presenters. So we'll be back in 2 seconds. Okay, so Luisa, welcome. So we have Luisa Pereira. Luisa is a computational artist and musician living in Brooklyn, New York. Her interactive music pieces have been exhibited internationally. She has collaborated with musicians like Björk, Saint Vincent, and Hero Dragon at the interactive and generative music installations. Also, she's an assistant art professor of the interactive telecommunications at the New York University Tisch School of Art. So, so Luis is going to present an educational project called The Code of Music, right? Mm-hmm. So please, Lisa, the floor is yours.
Thank you so much. Thank you very much for having me. It's I have known about the music and technology group at UPF for a long time, even before I moved to New York in the early 2000s, I think. So it's a real pleasure to meet you all. Today, I'd like to tell you about this project I'm working on. And it's a book about creating interactive music in the browser. But first, I'd like to give you a little context of where it comes from. I teach at ITP It's a department at NYU that focuses on imaginative uses of emerging technologies. We call ourselves a Center for the Recently Possible. And there I teach a number of courses on music, interactivity, and computation. And students combine techniques from music theory, creative computing, physical computing, musical production, and interactive design in these classes to create anything from web-based compositions and tools to physical installations and instruments that they perform with, like the one you see in the picture, Adrian's reimagining of tinikling Filipino traditional music. They often use AI as sensors in their projects. Here, if we could maybe play the video with the sound. This is undergraduate student Lisha Payne showcasing her study on harmony. A machine learning model is detecting her mouth and how open it is, and she maps this into the character on the screen who sings a part in a harmony that she's playing with the keyboard. One interesting thing about this program is that because of the multiplicity of cultural and professional backgrounds, even with graduate students, I can make no assumptions about students' previous knowledge of music or technology. I might have a Brazilian student who is not sure what a chord is, but is an experienced software engineer. I might have a Chinese student who is a professional jazz musician and a beginner programmer, for example. So having found no materials that fit this particular teaching context, I started creating my own. And I'm currently in the process of turning lecture notes, code examples, and interactive illustrations that I've designed over the years into this book called The Code of Music. The book is structured in 3 parts. We start from a holistic perspective, having students create audiovisual instruments. Like you see on the screen, it's okay, we can't listen to the sound. And interactive compositions that are based on stems and loops that they can find or record themselves. The idea here is that from the start, students connect the music they are already familiar with or enjoy making with the work we do in the classroom. And this is in response to my noticing, in my experience, that classes that start from the physics of sounds and oscillators, for example, tend to attract or retain mostly students who are already interested in those things, which is a small subset, of course, of the people who are attracted to music. And also in response to noticing that often tutorials and library examples make assumptions about people being already familiar with the language and notation of Western classical music, which is also a small subset of people who make music, even in the West. Of course, these might make sense in their context, but it doesn't make so much sense in my teaching context. Sorry, I got lost in my slides a little bit. So we start from this holistic view. And then when students create interactives at this holistic level, they start to be curious about the creating interactions with the elements of those compositions. They want to create interactive melodies, interactive harmonies, interactive timbre. And that's what the second part of the book deals with. To give you an example, we focus on one element of music at a time. Here's the beginning of the melody chapter, and it's in progress. First, we present the concepts of pitch, duration, tuning systems from different cultures, modes and scales, contour, range, via a series of interactives. In the video, some are already implemented, some are designed, and then code examples to show students how to represent these concepts in code so that they can create their own interactive melody studies. I'm going to show you one, and you can't hear the sound, but this is okay, from an undergraduate student, Kyle. This is a classic sequencer interface with the twist that you are seeing how he's changing how many pitches the octave is divided into. So you can go from, just 2 notes in an octave to a microtonal sequencer just by changing one with the play of a button. Another example is just this semester, one of my students who is from India designed an interface to generate melodies based on different rags. And then when she went to implement it, she quickly ran into assumptions about pitches that were baked into a sampler object. She's a software engineer by training, so she plans to come back to this idea over the summer, and we'll work on implementing this project. So both of these are 1-week projects that students have created after that lesson on melody. So we start from a holistic view, then dive into elements. And the third part of the book covers algorithmic approaches to generate music, starting from Markov chains, and then as an example of rule-based systems to L systems like you see and can hear and what you can imagine in this lovely musical garden by Elias Jarzombeck, and finally neural networks. So by design, by the time we get to AI, it is a tool like any other. And this is a bit of a response to the tech world's and even our program's obsession with the new, which tends to skew to a certain demographic. My hope is that by the time we get there, most students are engaged, feel like they belong, they're supported, and their contributions are valued, whether they fit that demographic or not. So you might have noticed my focus on inclusion. I think this is crucial as we build more and more AI into our music making tools, and whose cultures are we crystallizing onto our models, for example, right? And this approach comes from experience. I wear many hats, and I have worked for 15 years as a programmer and a creative technologist. And I have never once had a female colleague in a similar role to mine. So I see this as a blessing now, because it's made me, this experience made me able to perceive the barriers that other misrepresented groups face as well, which is useful when I teach in a multicultural program like ITP. And really, this is why I teach, and why I'm writing this book. I'm hoping to make my modest contribution to make the field more inclusive and bring more diverse voices in. Thanks.
Okay, Luisa, thank you very much for your comments. Well, it's a very interesting all the approach that you have shown and the work that you have done with the students. And I see, while I was looking at your presentation, I was thinking that there is a very direct link related to the Tell Me project that Rafael and George presented at the beginning, and based on, as well on my own experience regarding on how can music can be visualized, and how these visualization are informative to music students at many levels, not only in terms strictly of musical information, so to say, pitch or rhythm, but more high level aspects. No, so I don't know. Well, maybe you want to extend on these comments.
Definitely, I think the layered approach is very interesting to me, and even in my artistic practice, I think I later saw that what I was doing was considering how music works at the physics waveform level, at the music theory level, and make an interface to understand it better, and then at the cultural level, and then make an interface to interact with styles. So this is a very relevant comment to my particular creative practice. What I've always done is bring my skill sets as a software engineer and as an interactive designer into creating, understanding music more deeply. And it's also, I have definitely brought this approach into teaching, because I find that it's this thinking of layers of low level high level, there's so many layers in music, and that means there's so many points of entry for people to be interested, to become interested in technology and in creating technology and in designing interactions. And I find that to be a rich and open way to present this.
Yeah, very nice, very nice work, Lisa. Thank you very much for your participation. We are going to move to the debate, so stay tuned. We will be back in short. Okay, so we are going to start with the debate of this afternoon. So before starting with the comments and the questions from the audience, remember that you can post your questions and your comments at the chat, and we will be presenting your questions here. So I would like to give the word to Enrique and Alia. They wanted to present and comment some reflections around these topics. So perhaps we can start with you, Enrique, so we can give some ground to the discussion.
Okay, thank you very much, Sergio. First of all, I have to recognize that I'm quite impressed about the projects that have been presented here. I know some of them. I have no idea about the third one, but I'm impressed. And before the decision this afternoon, I checked a little bit about your names and studied the projects and what are you doing. And there are some reflections that came into my mind in order to provoke a little bit the debate. So what I'm going to say is a little bit provoking. So maybe this is not my ideas, but these are just some ideas that I want to put to open to all of you in order to start the debate. And more or less, I have three questions, three reflections that maybe each one is more focused on one of the three projects presented. The first one is maybe more related to Tell Me, is that, well, as is it written here, I belong to the SMUC, which is a school of music for bachelor students. And many of the teachers that teach there also teach in schools with kids, with children, and so on. Anyway, the technologies proposed by Tell Me are amazing. From the technological point of view, are amazing. But I cannot imagine a music school from a small town using them, because of the setup, because of the resources of the school, and so on. And moreover, last week I participated in a debate from European Association of Music, School of Music, and so on. And they insist, especially now with the crisis, with the Corona crisis that we have right now, in which the participation of the parents when the kids learn music is crucial. So without the parents, the kids cannot learn music in this pandemic solution, in which these technologies like Tell Me are completely fabulous. So they can help a lot in this situation. But maybe the parents have not, maybe the economic possibilities, maybe not the technological knowledge enough to use this tool. Maybe it's a matter of time. So this is one reflection that I send to the floor, and maybe someone of the audience in YouTube can respond, or maybe the comment of the people of the project, Rafael or George. The second one is related to the. I just sent ideas. Okay. Yeah, after that we can start the debate. The second is related to the project of Anna. This is amazing. So it's two steps in front of us, in the sense that you are doing live coding, which is not easy in a music school. Try to try to teach, or for the students' point of view, try to learn live coding, because they are used to play violin, not live coding. And you go even beyond, trying to use machine learning to for live coding. So this is 2 steps in front of us. In that sense, what I can experience with the students are more close to me, belonging to the sonology department. Maybe we need to think, as a music school, we need to think in some types of music that have no sense without artificial intelligence. So I mean, not trying to replicate, improve, extend the current techniques or situations in class, outside the class, or whatever, but trying to think musics that have no sense, that we cannot imagine without the use of artificial intelligence. And I think this is one I am very keen on this idea. I really like very much, and I think the project of Anna is quite related to that idea. Okay, so try to use artificial intelligence not to recreate or reproduce things or improve things, but try to go beyond, thinking on music that cannot exist without artificial intelligence. This is another key from the musical point of view. And the third reflection is related to the third project, in which Luisa, you show that the students, in fact, if I understood properly, they were coding. It's hard to try to teach coding in a music school. Okay, but they tried coding. But for sure, at least in my experience, how could I say? Coders, the good coders are not from music schools. Okay, the people who can take and imagine things and try to code, it's not people coming from music schools. In that sense, maybe the musicians or the composers of the future, of maybe in 10 years beyond of us, maybe they are people coming from computer science with a little bit of knowledge of music, instead of people with a big knowledge of music with a little bit knowledge on computer science. So where is the balance? I don't know. The ideal is to be expert in the 2 sides. But I don't know if you have experience in that sense, if the students that are more close to these initiatives have one specific skills or the other, or so on. So these are my 3 reflections that, looking to the projects, I think that I came out from them and just put well, for all of you that who wants to ask beyond or answer or whatever. So thank you, Sergio, for these minutes.
Thank you very much, Enrique, for your reflections and your contributions. So now I would like to give the word to Alia. So Alia is going to share some reflections around the topics as well. So Alia, welcome.
Thank you, Sergio. Thank you. I'm very happy to be here. And yeah, so I guess I don't want to drift too much from the provocations and reflections that were just mentioned, so that we don't forget them when we address them. So I guess a bit on my background, I'm more related to the context of Tell Me, which was just presented by Rafael and George, in the sense that in my PhD, we are trying to use technology as a way to enhance traditional music learning or traditional learning of instruments. And I have to say that it is crucial. And I guess this touches a bit on the third provocation, where there needs to be more interaction between the musicians and the technologists, so that the things that are created essentially are more relevant and serve the music teaching and learning context. And so I guess based on my focus, I'm trying to focus more on, because I mean, there are many things that have been done for a music learning context, and it's evident by the different apps that are arising, which should make things a bit more accessible, despite the concern raised earlier by Enrique that maybe it might be a bit inaccessible to some parents and some teachers and learning in some contexts in villages. But so until today, technology is unable, for example, to determine whether a particular music score is difficult or easy. There has been improvements in some tasks and some things related to gesture recognition. And as has been indicated by George, that when these technologies have been used in actual learning contexts, I quote, you said that there was twice the amount of improvement in 10 minutes was shown in one of the tasks. And this is very fascinating. But if we want to do something on a more fundamental level, I think it would be important for us to be able to help students organize their learning material, for example, and be able to identify which scores could be useful for them. Because also in the traditional learning context, we assume that we already have music scores that are like separated by difficulty level. And in the more modern learning context, where people are more self-directed, or they want to learn a song and it can be a multitude of arrangements for that song, this is still not on the table. So I guess this is one of the challenges that I hope can be addressed. But also I want to ask a question to everyone basically on the panel. In your interaction with people who are learning music, so what are other kinds of interactions that music teachers and students feel that they are missing? Because I think that this is I think a very good starting point that we don't really hear too much on. And there's always the risk that the developers of the technology are computer scientists who know a bit about something and then they lead the direction. And this is a concern in many of the technology-enhanced learning topics, not just music. And yeah, so I guess that's my main question. I would love to hear more on this perspective. And yeah, I hand the floor back to Sergio.
Okay, thank you very much, Alia. Okay, so before going to the public questions, I think we will give the word to Rafael and George, perhaps to go around with the topics that Enrique and Alia have set down into the ground. So maybe Rafael or George, if any of you wants to comment.
Shall I? Oh, sorry. Go ahead, Rafael.
No, ahead, George. You go, brother. You go.
Okay. Well, maybe I'll start with sort of Alia's points later there. So I think there were sort of two questions. So one about technology's ability to help organize the massive amount of music that musicians need to learn, can choose from, and also a question about what are the other interactions that we can have as musicians and teachers. I mean, they're fabulous questions, and these are certainly things we thought about within the Tell Me project. Raphael mentioned at the start of the session that there were a number of partners involved within Tell Me, and there were a number of technologies that were worked on. Skynote, that Raphael demonstrated, it was sort of the flagship, sort of the central technology, but there were a number of other ones as well. So Raphael mentioned the company High Skills that was involved. So we at the Royal College of Music worked very closely with High Skills, and there are two additional technologies that came out of the project. One, what we call the Tell Me Planner, which, as you describe, it's a tool that helps musicians organize their materials. It has an intelligent catalog that lets you upload and store your scores and recordings. It lets teachers put together different packages of scores and sequences of them so that a student can go from one to the next, with even the potential of having something like Skynote and similar artificial intelligence systems help guide when you've mastered one and are ready to move to the next. And potential as well too to build it out to a network where one can access a larger library of scores. The Royal College of Music, for example, has just quite recently signed a deal with the company Encoda. So now every single student and teacher at the Royal College of Music has access to hundreds of thousands of digital scores wherever we are, our own sort of personal digital library of music through the college. So you can imagine having that resource and adding on top of it a layer of artificial intelligence helping guide our way through that. On the point of other interactions that people can have, one of the ones we were particularly interested in is the model of a studio class. So where you have not just this teacher and one student, but a teacher and several students. And what often happens is each student takes in turns performing, and they get feedback from each other. And this is very valuable because it's not just an opportunity to perform and to get feedback from your teacher and your peers, but it's an opportunity to give feedback, to develop your own ear, to develop your ability to assess and to offer criticism and constructive advice for other performances. So on that front, we developed a platform called Master Studio, and the idea is you can take that entire model of a studio class, or a faculty class, as it sometimes gets called, and have it operate entirely online, and crucially asynchronously, so everyone doesn't have to meet at once. It's a process of uploading videos, and those videos being assessed and commented on and shared by each individual, and the software takes you through that process. So in fact, we're with High Skills, we're in the process right now of looking to commercialize this. Literally yesterday and tomorrow, I have more meetings as we move towards this. And we hope that these technologies that came out of Tell Me will be available to the public relatively soon, something that can start being put into practice. And maybe if I could just sort of circle back to one of the earlier points that was raised, we heard about the question of availability of technology and whether students and parents will use it. I fully agree. What we see as one of the biggest barriers to technology take-up in musicians is it difficult to use? It has to be so easy for them to use. And so obviously useful for them to even give it any consideration. Musicians are just very busy. They don't have time to struggle with technologies that they don't know how to operate, that they don't understand. And also, a lot of musicians don't have a lot of money. So using technologies that we already have is very important. And what really excites me is when I started my undergraduate piano training in 2006, at the time, I bought a handheld video camera. And at the time, this just felt incredible that I could record my own video and see myself perform. And my teacher essentially mandated that I buy this. So musicians are willing to invest in technology. I mean, they spend 5 or more figures on their instruments. And in the time since, well, we now carry supercomputers in our pockets. That's, even in the last years, we're now seeing motion capture technology. We're seeing artificial intelligence and neural networking that we carry around with us, or we wear it on our wrists, or very soon we strap it onto our face. In another 5 years, what unforeseeable technologies are going to be in people's pockets? And all we need to do is be ready to ride on that sort of wave of incoming technologies that people are already engaging with anyway. And make sure that we have technology that aligns with, as I said before, the sort of the traditions and techniques of musicians, but making use of what they already carry with us. And it's been very exciting, working with UPF and the whole team there to see what they can do with a simple accelerometer on the wrist, and being able to extract from that all the intricacies of violin bowing and things like this. So I agree that 5 years ago, or even 1 year ago, or even maybe right now, the technologies aren't quite in people's hands, but in 1 year's time, in 5 years' time, there's every reason to think they will be, and we should be ready for that when they have those technologies available to them.
Well, very much, George, for your answer. We have a question from the audience, and we believe this is related to Anna's work. So the question is, I am really interested in the project you talk about related to roadblocks faced on a building interface related to the ragas. So I don't know if
it's Lisa, right?
Yeah, maybe.
Yeah.
Sorry, it's Lisa, right? Yeah. And also, Luis, if you want to extend on the previous questions that were related to your presentation.
Perfect. Yes, I'll start with the question from the audience, Aditya. So this was my student Stuti in my class this semester, and she did create, I think it was a sort of sequencer that would be filled with random melodies that with following patterns from ragas adapted to the Western tuning system. But she told me, it sounds so robotic. It doesn't sound at all like the music I'm trying to convey here. And so I suggested she use a sampler instead, because she was using a synthesizer. And she did find samples of the instruments to get the timbre, the texture she wanted. But then the sampler didn't have an easy or immediately apparent way to slide between notes, and certainly not between notes, between frequencies that were outside of MIDI notes, outside of the Western notes. So she struggled with it for a bit, and she's an engineer, so she could and she was using an open source library whose author, I'm sure, would be very happy to add this, this feature. And she could definitely contribute to it herself. But this being a week-long project and her having many interests, she ended up going in a different direction for that time. So that's what happened in that particular case. Oh, and I guess I should comment on if there are any comments of this. Otherwise, I can comment on the other question.
The other topics that Enrique and Alia commented around your work, or
yeah, sure. So Enrique asked the question of what he was saying, where will the musicians of the future come from, right? If coders are usually not that imaginative, and musicians might not be as prepared to code, and how do I see that? And I will say, I really hope that some of the musicians of the future are my students and students of other people who have this multidisciplinary approach. In my classroom, in fact, many students are neither coders nor musicians. And often they are the ones who come up with the most imaginative concepts. So I separate assignments so that everybody has somewhere to contribute, right? Graphic designers shine on the visual part, musicians shine on the sound design and the composition and the improvisation, programmers shine on the implementation part. So everybody has somewhere that they can shine. And the people who are maybe, I even have doctors or lawyers sometimes in my classes. And they're very, so I split the projects in conceptualizing, so asking people to sketch ideas, imagine many ideas, and implementation, pick one and make it. And in the ideas, it's amazing how it is often the doctors and lawyers, or people with other professions than coding or music, who come up with the most novel ideas. And I would say also that one thing I've observed that I find quite interesting in these classrooms is that when I talk to students one-on-one, they will often say, I ask them, how are you feeling in the class? And they will say, I am so intimidated by how talented everybody else is. And this is true. The programmers feel they're not creative enough. The musicians feel they're not technical enough. The designers feel like, it's all, but the beautiful thing is that throughout the semester, they're all inspired by each other, and they recognize both what they can bring into it, and they learn a little bit of the language of the other approaches. So to answer your question, I hope that this kind of approach brings us new kinds of music and musical tools and approaches in the future.
Okay, thank you very much, Lisa, for your comments. So I would like to give the word to Anna. So Anna, if you want to comment on some of the questions raised by Enrique and Alia related to your work. I think there was one very, very interesting that's which is the music that cannot exist with AI. No, I think that is a very, very nice point to start, maybe, or wherever you want to start.
Yes, sure. Thanks. I can start with Enrique's question, and I guess using music technology or new technology, there's always the aim, I guess, to find or explore new music. So yes, I would agree that by extension, using AI, you also seek for new music, explore new timbres, new ways. And then also I agree that it's a double challenge. So asking, like, there are these two contexts, I guess, the live coder, but also live coding has been used in teaching environments with successful examples where students learn coding and making music. But here is this double challenge: learn to code, even if, and also it could be learn music, but also learn AI. So it's kind of, yeah. But I would say it has like a double benefit as well, in the sense that you can get more customized. So yeah, following this model of that you can create your customized or adapted tool, you can get also like very unique sounds from this effort. So yes, it's a bigger challenge, but probably the benefit is bigger as well. So I guess that would be the way of selling selling the product. And also, yeah, just to mention, so in the context of live coding, also like keeping the AI brings like this agency, which is very important for live coders to keep this agency, and really very much speaks with already the nature of live coding, of this DIY culture and open culture where you share, but also, yeah, you can just customize and adapt the tool to your own needs. And yeah, just wanted also to comment on like using like this live coding and AI in kind of educational context that could also inform or expand what is like these initiatives called STEAM, or adding this science, technology, engineering, math, and arts. But then it's a nice kind of follow-up, bringing AI into like these STEAM initiatives where you are bringing the arts, and through the arts, you just raise awareness and also interest, spark interest about like more scientific and computational areas. So yes, I guess one goal would be to make more user-friendly tools, easier to install, so then students can get focused on kind of the algorithms and these benefits. And then following up with Alia's question on kind of bringing or exploring other ways of interaction. So live coding can be quite constrained with the code, but I wanted to mention we had some speculative workshops during the kind of the delivery and development of the tool. It has been quite participatory design approach. And we had some speculations. There are some interviews on the website with live coders, and Hernani Villaseñor, for example, he mentioned imagining, like from using this tool in his practice, he was imagining using more like spoken word and voice in the interaction, in the training, and in the performance. So I guess we can use these tools also to speculate how we want, and these other new interaction styles. What do we imagine? So yeah, I guess we are still early stages, but it's a good kind of way of yeah, speculating, but also shaping what can be next.
Okay. All right, so thank you very much. Anna, we have one question from the audience. Okay, so it says, with more inclusion of artificial intelligence in music technology area, what would future bring not only for music learning, but having a more creative music experience? So I don't know who wants to perhaps comment or on this question. Perhaps, I don't know, Rafael. Okay, thank you, Rafael.
I was muted, so I wanted to say. So I think artificial intelligence is a great tool not only for extending the kind of possibilities that you can have in artificial in music education or in music creation, but it's like a kind of two ways, and we can see it now with technology, with music technology. If we were involved in a project in which we were teaching, when it was a music composition, song composition in primary and secondary schools with technology. It was not artificial intelligence, but it was just tablets with some technology, with nice programs to compose. And it was incredibly interesting how children who have never touched an instrument, have never sung any melody in their lives, they were completely not musically educated, the impressive things they could create with technology. And this, on its turns, came back, because once you see music is fun, you can create songs, it sounds nice, you start to gain interest in playing instruments. You want to go back to the roots and say, okay, if I can do it with technology, why don't I learn to play the guitar? And then try to complement what I've done with technology. So in the case of artificial intelligence, it's going a step further. It's not just music technology, it's incorporating intelligence into these music systems. So then we can kind of inspire, at the same time provide like a more personalized way to learn and to produce music, and then on the return it will feedback to traditional music making, I think. So it will make creative, put creativity into people in order to use whatever they want to express their creativity. It's just a great tool to encourage people to be creative.
And if I could add to those very important points, something else we looked at with Intel was also musicians' health. So this is an area that we study a lot in the Center for Performance Science. And people are often surprised to know that among student and professional musicians, the rates of injury are the same as professional athletes. We don't think of music being a very physically demanding activity, but it really is. And there's an epidemic of pain, of injury among musicians, and that, just on the physical side, never mind the strain on mental health as well. And it's been very exciting to see the potential, not just in music, but other areas such as sport, for AI to identify injury before it happens, to see those slight differences in the complex motions that a musician makes, and to recognize where excess tension or excess tightness or inefficient movement could lead to injury in the future. And of course, it's very difficult to have fulfilling, creative musical experiences when you can barely pick up your instrument because it hurts so much. So I really look forward to, as well, of artificial intelligence being able to not just help musicians recover from injury, which is a very difficult process, but actually prevent those injuries from happening in the first place.
Okay. All right, so thank you, George. I think there was another question from the audience. Let me see. Okay, yeah. So this is another question for Luisa. So it says, I worked on Markov automation to present and generate a raga and face the same problem. Inclusion of musical cultures would go a long way to solve these problems. So, Lisa, you would like to extend on this comment?
Yeah, I agree, and I think. Oh, there's an echo. I think maybe. Let's try again. It's gone. I think the crucial thing that at least I'm focusing on is bringing more voices into the technology literate interface creating group of people, because in the program I teach particularly, a lot of our graduate students go on to work for the industry, for the tech companies that design the interfaces that then become the tools that shape the next generation of music. So really making sure that there's the diversity of people in those rooms where those interfaces are being defined will give us just a lot more richer ecology, or a richer ecosystem of tools and different ways to engage with music. And to just touch on the previous question, I think AI and technology in general, how will it give us a more creative music experience? And I think it is by multiplying the ways in which we can engage. And like Rafael was saying, someone who doesn't have music education, but we are all, hearing people, and even non-hearing people. One of the projects from a student that's being presented next week, and you're all invited to Thesis Week. It's going to be streamed next week. Pippa Kelmanson, she's working on an instrument that you hold and touch, and instead of creating sounds, she has some it's to some degree hard of hearing, and she uses bone conduction. So the what you get from the instrument isn't sound, but vibration going straight into your jaw. And so it's I just saw that beautiful documentation that she created. So, you know, I was just going to say, any level of music making, we can create ways for people to engage in many different ways, and AI can assist with that, just like Rafael was saying before.
Okay.
What tools do I use? Oh, sorry, is that for me?
Okay, thank you. Thank you, Lisa. So there is another question. I think it's related to the one that Rafael answered before. So it says creating interactions between paintings, color, and relating them to different music elements such as rhythm and pitch, etc., would create a new area of study and interest. So I don't know, perhaps or wants to comment on this, if you want to raise your hand, or I can give the word. Perhaps, Rafael, you can comment, start the discussion a little bit, and we can follow.
Yeah. I mean, there have been works. I mean, these interactions between kind of visuals like paintings or colors, and how they can relate to sound or music, rhythm, pitch. They have been like, actually, you remember that we had a student that was working exactly on that, how to map the soundscape into some visual scene, and the other way. So, but not just an arbitrary mapping. You can imagine all kind of mappings. You can just, whatever you decide, I don't know, pitch will be the tone between blue and red or something like this, but trying to make this in a way that it was quite like intuitive and in a kind of natural way. And the idea was that people looking at the picture, at the music, at the visual, could infer how the music sounds, and also the other way. If you could listen to the sound, you could imagine how this was done. And this has two applications. One was, in his case, he was artistic. He wanted to play concerts in which the visuals were really related in a very like organic way to the sound he was producing. But you can see it as was mentioned before, that I mean, that someone who cannot listen, you can enjoy music by looking by looking at the animation or the visuals, like Luisa was mentioning before. So it can be, I mean, and people have been doing this in the past, and it's a really interesting way to proceed, either for artistic reasons or for more like practical kind of disability guided reasons.
Yeah. I think that the topic is interesting. I remember in the Tell Me project that we were facing this issue of creating relevant feedback for musicians, as they have a very different mind setup for interpreting visuals. So we engineers, perhaps we love graphics and lines, but musicians, perhaps they prefer to see scores, right? So I guess this is a key point in this aspect, and it's a very, very interesting topic. So I think there is another question. We think it's for Anna. Philip Pasquier, he asks, what tools do you use?
Yeah, sure. So yeah, back to this challenge of on top of tools. So I have to mention that Milka is really built on top of different libraries. So it really depends on all these libraries to make it work. And it starts from Super Collider as a programming language and environment, as you know, for live coding and algorithmic composition. But then it's using the Freesound Quark to communicate with Freesound and all these sounds you've seen, like it uses the Freesound API so we can get all these sounds. But then Milk is kind of a higher level library that's a self-built library that kind of brings the liveness, if you like, of accessing this Freesound API through the Freesound Quark. And then Flucoma, very important, which is a new library that is built from a team at University of Huddersfield. They are building this creative tool set for machine learning, and it's suitable for SuperGlider and also MaxMSP. So I'm using Flucoma, or Milka is using Flucoma for the kind of the machine learning layer, in this case with the kind of the MLP. And then there's Milka, which is kind of the Milka is the higher level, and then it speaks or it's built upon all these tools, but yeah, based on the Milk class and also Flucoma. So all together, you need all these installed and running and working so that Milka works. So that's why, yeah, it's really a challenge, but then the benefit is bigger. So, and also I wanted to reply on that question about creativity. And when bringing AI as an additional kind of layer into the music technology. So as mentioned in this particular project, serendipity kind of has emerged as opposed to randomness. And I want to highlight that about, you know, when like retrieving sounds from Freesound, that there is this randomness which can be very good or very bad. So the serendipity kind of is brought through or by means of using AI, but also, and again, like this agency kind of brings more customized experience, if you like, and unique experiences. Yeah.
Okay, thank you very much, Anna. So we are going to go to 2 more questions before closing the session. They have to be very, very quick, so I am going to ask to the panelists to answer very, very briefly, very quickly this question. So one question is, are there online open source communities for music creation and technology AI that exchange knowledge? Generally, this ideology is rising, and I am sure that there are many, but any specific ideas? So I don't know, perhaps, I don't know, maybe Anna, you can...
Well, I would like to kind of follow up or also comment that during this week we organized 3 workshops, and in total we had 60 participants, and this need was also raised, or this question. So across different technologies they were using, it was raised that, you know, there's a need of this kind of community or space of exchange. So yeah, maybe that's, you know, something kind of to consider for future, like instead of focusing on particular technologies, having like this cross-disciplinary, cross-platform space of debate.
Let me add, sorry.
Yes, sure, Enrique. Go ahead.
That the starting point, I think, is to search in the conferences like MOCO, they don't come in my mind, the MOCO, maybe the SMIR, maybe the NIME, so the typical conferences in which the authors write their articles and expose their jobs there. So starting from conferences, I think it's a good starting point to meet people and know what are they doing.
Yeah, definitely. Okay, thank you very much, Enrique, for your comments. So this next question, I think, is better addressed to George, perhaps. So how can help artificial intelligence in the preservation of ancestral, tribal, or ethnic music or songs that are part of the historical heritage of humanity? Is it possible? Perhaps George or maybe Luisa can comment on this topic. Or Rafael, you want to
Yes,
Okay.
just very briefly, there are projects going around, and artificial intelligence has been applied to recognition of scores, to digitalization of old heritage music. And I know 2 or 3 projects on that take really old manuscripts, and then by optic, basically taking the image, they will digitalize this because they are quite sparse and so on. So they are trying to put everything together into one place. And not only that, but then also the ones they have been digitalized, then MIR, or music information retrieval techniques, can be applied to group them, to make them organize this big data set of music.
Thank you very much. Enrique, if you want to be very brief, we are.
I will be very brief. 10 years ago, I collaborated with a couple of projects with ethnomusicologists. One was about how is it called, the people who takes care about the sheep, the shepherd, el pastor.
Shepherd, yes.
Shepherd, right, you're right, the shepherd. That most of the shepherds around the Mediterranean area, which is the old Roman Empire, share a similar language by calling or organizing their animals. Very different than north of Europe. So it was 10 years ago, but for sure, if this project were right now, I would use machine learning techniques from recordings and so on, right, to find them. And the other one relates to the size of the churches, the small churches at the Pyrenees, in which the singers that used to be there singing on Sundays, they were not professional singers. They were the big men of each house, so they were not singers. But most of the singers sang at the same tuning frequency. So all of them from all the Pyrenees were tuned. So how is it possible? Realized that it was possible because of the size of the church. That was there were similar sizes, and the resonance were quite close. But for sure, if the project started right now, I will also include in that project machine learning. In that sense, there are many ethnological projects in which you can include machine learning. These are some examples that I didn't use, but for sure I will include them right now.
Okay. Thank you. Luisa wants to.
I have one last short comment to broadening this question into the environment. I know of a very interesting project where they used machine learning to find. Well, they recorded hours and hours and hours and hours of whale song, and then it's how do you even find the interesting parts of this? How do you even listen to that? It's years of recordings, and they use machine learning to find new songs from the whales and know which season this happened, how many whales sang it, and so on. So that's another example.
Okay, thank you very much. All right, so we are going to move to the closing section of the event. So we'll be back in very, very short. All right, so before closing, for closing the event, we are going to see a video of a performance and of a composition by Luisa. So Luisa, if you want to briefly introduce your composition.
Yes, well, I wouldn't exactly say, it is my composition. It is a collaboration with composer Juliana Barwick. So the context for this is I created the generative systems for a series of installations in the lobby of a hotel in New York in the Lower East Side. So we installed the camera in the rooftop, and the machine learning algorithm was detecting patterns of what was happening in the sky. And then the system that I made would run in the lobby and take those inputs of what was happening flock of birds is flying by, different kinds of clouds, time of day, planes, and so on, and would affect the music that was playing in the lobby. And we did 2 versions of this project. This was for the Sister City Hotel in New York City, and it was a client project. The client was Microsoft, who had a new AI toolkit. And one of the versions was in collaboration with Björk, and she gave us access to her choral archives. The many recordings, her favorite choral recordings from her albums over 10 years. And after discussing with her, I made a system that chose which arrangements to trigger when, depending on what was happening in the sky. But what we're going to hear now is a completely different version, even though the setting is exactly the same: camera on rooftop, system in the lobby. This was a different composer, Juliana Barwick, that I mentioned. And if Björk had like bursts of sound, which is what she wanted, discrete of these choral clusters, Juliana's style is a lot more like a field of overlapping synthesizer, dreamy vocals and synths. And this is what you're going to hear now is one of the potentially infinite arrangements of this piece that's generated by the system I designed, keeping in mind or modeled after Juliana's composition style. And it's a piece for the evening, for night.
So we thank you very much, Luisa, for your video. And we are going to close the session now. Just to wrap up, well, this is the last session of the creative AI music proposed by Artificia. And very quickly comment that Artificia project is committed to continue offering activities to democratize the knowledge on AI applied to the arts and to discover the power of artificial intelligence in its co-creative potential. So keep in touch with the site and the social media activities. Thank you very much to all the panelists for sharing your work, and also thank you very much for the audience for your nice questions and contributions, and hope to see you all very soon. So good night and take care.